Welcome back to Java Internals Crashcasts. I'm Sheila, and with me, as always, is our Java guru, Victor. Today we're continuing our exploration of concurrent design patterns, and we'll be diving into the fascinating world of thread-safe singletons. But before we start, let's kick things off with a fun quiz question for our listeners. Victor, would you like to do the honors?
Certainly, Sheila. Here's a question to get our listeners thinking. In a multi-threaded environment, what potential issue could arise if a singleton is not properly implemented as thread-safe?
Ooh, that's a great question, Victor. It really makes you think about the implications of concurrency in object creation. I'm sure our listeners will be pondering this as we go through the episode. Now, let's start by explaining what a singleton is and why we need to make it thread-safe.
Absolutely, Sheila. A singleton is a design pattern that restricts the instantiation of a class to a single instance. It's useful when exactly one object is needed to coordinate actions across the system. Think of it like a country's president. There should only be one at any given time.
That's a great analogy, Victor. So, why do we need to make it thread-safe? I imagine it has something to do with multiple threads trying to create the instance simultaneously.
Exactly right, Sheila. In a multi-threaded environment, if we're not careful, we could end up with multiple instances of our singleton, defeating its purpose. This can happen if two or more threads try to create the instance at the same time.
I see. So how do we typically implement a singleton, and what are the thread safety concerns?
Let's start with a basic implementation and then discuss its thread safety issues. Imagine we have a class with a private constructor and a static method to get the instance. If the instance doesn't exist, we create it. Otherwise, we return the existing one. However, this simple approach isn't thread-safe.
Oh, I see the problem now. So how do we fix this? My first thought would be to use something to control access when multiple threads are involved. Would that work?
Good thinking, Sheila. Using a mechanism to control access is indeed one approach. We could use a special keyword in Java that ensures only one thread can execute a particular method at a time. This solves the thread safety issue, but it's not very efficient because it controls access for every call, even after the instance is created.
I can see how that might be a performance bottleneck. Is there a more efficient way to implement this?
Absolutely. One popular approach is called double-checked locking. It's a bit more complex, but it's more efficient. Essentially, we check if the instance exists before we use our access control mechanism, and then we check again inside the controlled section. This approach only controls access the first time the instance is created.
That's interesting. I notice you mentioned we need to use a special keyword to ensure changes are immediately visible to other threads. Can you explain why that's necessary?
Great observation, Sheila. This special keyword is crucial here. It ensures that changes to the instance variable are immediately visible to other threads. Without it, other threads might see a partially initialized instance due to how the computer optimizes the execution of our code.
Wow, that's a subtle but important point. Are there any other ways to implement a thread-safe singleton?
Yes, there's another approach that's both thread-safe and only creates the instance when it's first needed. It uses a special nested class to hold the instance. This approach is thread-safe without requiring explicit access control.
That's elegant. It seems to leverage some guarantees provided by how Java handles class initialization. Are there any other approaches we should know about?
Indeed, there's one more worth mentioning, the enum-based singleton. It's the simplest and most robust. We simply define our singleton as an enum with a single instance. This approach is guaranteed to be thread-safe by Java, and it's also safe when saving or loading the state of our program.
These are all fascinating approaches, Victor. What would you say are the best practices for implementing a thread-safe singleton?
Great question, Sheila. The best approach often depends on your specific needs, but here are some general guidelines. 1. Use the enum approach if you don't need to delay creating the instance. 2. Use the nested class approach if you need to delay creation. 3. If you must use double-checked locking, be sure to use the special keyword we discussed. 4. Always make the constructor private to prevent creation from outside the class. 5. Consider using a dependency injection framework instead of singletons for better testing and flexibility.
Those are excellent tips, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly, Sheila. The answer to our quiz question is that without proper thread safety measures, multiple instances of the singleton could be created if multiple threads attempt to initialize it simultaneously. This defeats the purpose of the singleton pattern, which is to ensure only one instance exists.
Thank you, Victor. To summarize today's episode, 1. We learned about the singleton pattern and why thread safety is crucial. 2. We explored various implementations, including synchronized methods, double-checked locking, the initialization on demand holder idiom, and enum-based singletons. 3. We discussed the importance of ensuring changes are visible to all threads. 4. We covered best practices for implementing thread-safe singletons. In our next episode, we'll be discussing performance and scalability in concurrent programming. Don't forget to subscribe and rate our podcast if you're enjoying the content. Until next time, happy coding.